Hello, our most developed student. My name is Confident and welcome to the calculation of KC for those of you who are doing their physical science grade 12. And in this particular series of videos, it won't be one. I will focus on the KC from previous exams, mainly the prelim, the one that was the prelim in Gauteng, the prelim in Mpumalanga, the prelim in KZN, as well as Eastern Cape. Now, in all these questions, I'm focusing mainly on what? On KC. You need to grab hold of these videos. Watch the whole part of these videos because it will give you an idea to see how the examiners bring out questions in KC. And once you can get hold of all this, you are in a better position to answer KC. You will see as you follow up what I mean. Okay, let's get started with the first question from Gauteng. As I say, it's a question on KC. So let's start with the first question. It says here, the balanced equation below represents the reaction that reaches equilibrium in a sealed container. So they are showing the equation of the Haber process, the ammonia plus hydrogen to make, the nitrogen plus hydrogen to make ammonia. And remember, delta H is less than 0. It simply means that it's what? It's exothermic reaction, meaning it releases heat. So here delta H, or the heat of the reaction, is negative. Now, to increase the yield of ammonia, adjustments are made to the temperature, pressure, and concentration of the equilibrium mixture. The graph below represents the result obtained. So this is the graph of concentration versus time. In as much as I'm answering KC, I just want to go through the whole question, and this question has 1 marks, 20 marks. Look at this. It says identify the changes made to the equilibrium mixture at each of the following times. What happened in T1? Let me quickly go through that. T1. Now, if you look at T1, the only thing they did, look at the nitrogen. It was going straight. Are you seeing that? Meaning nitrogen, hydrogen, and ammonia, it had reached already some equilibrium. And then all of a sudden, you are seeing nitrogen going up. Meaning, when you see that, they added nitrogen here. They added N2. You see that? So now the question is identify the changes. Now the changes is what? Here the change is in concentration, because they are saying to increase the yield, they made adjustment to temperature, pressure, and what? And concentration. So if you see that spike that goes up, it's what? Addition of nitrogen here. Increase in concentration of nitrogen. Are you with me? So that's the first part. That's what happened in the one. What about T2? If you look at T2, something is interesting with T2 again. The equilibrium was established, but look at it. There is that spike that looks even. It's like the similar kind of spike. And the only way you can change something same time. But let's look at the yield also. Let's look at the yield here. Let's look at the yield. Look, after that, nitrogen, look at it, where it's going. Nitrogen was high, started decreasing, and then yes, hydrogen also started decreasing. Okay, so nitrogen and hydrogen started decreasing. So, and then look at the ammonia. Ammonia increased. And the only way we can try to get a reason of that is, look at this. This is 1 mole. These are 4 moles. This side give us 2 moles of what? So it's 4 moles of reactants give us 2 moles. You add 1 plus 3. So it's 4 moles of what? Of reactants give us 2 moles. So for us to see an automatic change whereby the yield, that's the key one, the yield is increasing here. Look at the yield, ammonia, you see that is going up. So you can see that here its pressure was increased because everything is affected equally. the nitrogen went up, hydrogen went up, ammonia went up. So it means they changed pressure. Why? Because both the products were affected at the same time. All right, so they managed to change here the pressure. That's the only reasonable part that was adjusted in terms of temperature, concentration, and pressure. You can't change the concentration on all the three at the same time, including the product. I mean, the product of ammonia. You see, it also went up. Lastly, let's look at another equilibrium was established, and then what happened this time in T3 now. In T3, look at ammonia, the dotted line. It's going down, the yield is going down, but look at it, the products are going up now. This reaction is going backwards now, whereby nitrogen is increasing. You see, hydrogen is increasing, but the ammonia is going down. And the only logical explanation here, this is delta H, meaning this reaction is exothermic. So for it to go backwards, it means the increased temperature here. Remember, if it's exothermic, you must decrease temperature because the reaction actually produces what? Heat. So when you want it to go backwards, it means temperature increased. And that's why the reaction went backwards. I see that. Alright, let's not waste much time there. As I said, I'm interested going down to KC. State Le Chatelier's principle in words. Guys, I say this is your duty to ensure that you master Le Chatelier in a simple way. Cram it with understanding, of course. So what are the keywords in Le Chatelier's principle? It says, let me write it slowly. When a closed, I'll underline the keywords, closed system in equilibrium, right? So when a closed system in equilibrium is subjected to a change, right? The system, the second part now, the system will readjust itself to establish. You need the 2 marks, isn't it? So you just have to write everything. When a closed system in equilibrium is subjected to a change, the system will readjust itself to establish a new equilibrium. All right. By favoring, I think that's right, by favoring the reaction that opposes the change. That opposes the change. When a closed system is subjected to a change, so that opposes the change or the disturbance. That opposes the disturbance or change. Another word there is that opposes the change. Alright, let's look at the keywords there. It says when a closed system, they will mark you that closed system in equilibrium. Those are part marks. It's half mark. So they will mark you the half mark. They mark you half. Is subjected to a change. The system will readjust itself to establish a new equilibrium. They can give you a mark there to say half mark, new equilibrium, by favoring the reaction that opposes the disturbance. Then they give you half mark. Just be careful. Many approaches, but just those keywords of closed system in equilibrium, a new equilibrium, and the opposing of that disturbance or change. Alright, so that is that. Let's move on to the next one. The pressure of the reaction mixture in question 6.1 above is disturbed by increasing the volume of a sealed container. Now, the pressure and volume, remember, pressure is actually linked to volume. When you decrease the volume, you increase pressure. When you increase the volume here, you actually an increase in volume is a decrease in pressure. You must always remember this part. When volume gets bigger, the pressure gets smaller. Alright, So here what are they saying? They're saying the pressure of the reaction mixture in question, this above, is disturbed by increasing the volume of the sealed container. How will the change above affect the yield of the ammonia? Write down only increase, decrease, or remain the same. We just mentioned already on this, on the pressure part, T2, to say when you're talking about pressure, it's very important to know about the moles. Remember, we've got 4 moles on the left hand side and 2 moles on the right hand side. So you can see that the left hand side has high pressure compared to the what? Compared to the right hand side, which is low pressure. So when you increase pressure here, where will the reaction go? The reaction will go this direction, you see that, which has got low pressure according to Le Chatelier's principle. Remember, when you increase pressure, according to the Le Chatelier's principle, it says that it will favor the reaction that will oppose that increase in pressure. And how do you oppose the increase in pressure? You go from left to right. What does it mean? From 4 moles you go to 2 moles. 2 moles has got less pressure. So here what will happen? The yield. So if you are going to the right, you see that this is the yield. NH3 is on the right hand side, so the yield will go up. So that's what you can say here, to say increase is the answer. So the answer there it is, the yield of ammonia will increase. And then they say use Le Chatelier's principle to explain the question 6.3.1. So if remember again, we're saying 1 ammonia plus 3 hydrogen, all these gases, please, you get 2 NH3. But the key thing is the moles. So we are saying 1 plus 3 to get 2, meaning how many moles? 4. Here 4 moles of products, of reactants, not products, 4 moles of reactants. Remember, this is gases, so obviously it's G, that's why we're dealing with pressure. Gives us what? 2 moles of products. So now what we're going to say, they're saying use Le Chatelier's principle to explain this answer, the principle here. You are going to say increase, that's first part. What does the increase in volume mean? Increase in volume result, I can say results in increase, what did they say here? Let me just I'm making errors. The pressure in the reaction mixture is above is disturbed by increasing the volume. Okay, I see now. So increase in volume results in what? Decrease. Is the opposite. Decrease in pressure. So in this reaction, the first one, you see that the pressure will decrease, right? So I think I will need to come back here. Let me first not do this because I said increase remain the same, but I was looking this thing differently now. Let's first explain this. Increase in the volume results in what? Decrease in pressure, number 1. Number 2, when the pressure decreases, what do you expect to happen? When you decrease the pressure, remember this left hand side has more pressure and then there is less pressure, right? So increase in volume results in the decrease in pressure, and then you're going to say there is 4 moles of reactants and 2 moles of products. Just identify that. It's also good. And then we can go back to number 3. What happens now? And then you can say according to Le Chatelier's principle. Remember, they say using an increase, sorry, a decrease. I keep on saying an increase. A decrease in pressure, a decrease in pressure will favor the reaction. Remember, we just decrease pressure, so according to Le Chatelier's principle, the disturbance here is decreasing the pressure, so it will favor the reaction that what? That increases pressure. Increases pressure. That's what it is. So there was a decrease in pressure, so the disturbance here is decrease in pressure, so it will favor a reaction that will increase pressure. All right, number 4, the reaction that increases pressure is which one? Is the reverse reaction. All right, remember there is more pressure on the what? On the what? Look, there is more pressure on the reactants than the product, so the reaction will now go to this direction. That's where now I was looking at it. This is where the reaction will go. Are you seeing that? So the reaction that increases pressure, then you can put in bracket and then you say the backward reaction, the reverse. Let's use the reverse. A reverse reaction. Or you can say the reaction that increases pressure in brackets, formation of reactants. And then you can say will be favored. To oppose the change. Remember Le Chatelier's principle. So a reaction that increases pressure, reverse reaction, you can use a reaction that increases pressure, the reverse reaction, or we are trying to say the formation of the reaction, will be favored to oppose the change. And I can go on to number 5 and say more products will be formed and the yield will decrease. You see, there is the solution there, because they asked here what will happen to the yield. I was supposed to say what? Decrease. That's the answer there. Decrease. I said increased, but it was as if pressure was increasing. Here there is a decrease in pressure, so the reaction goes backwards. So here, write down increase, decrease, or remain the same. That is that part. All right. Use Le Chatelier's principle. I know I explained quite a lot of marks, and then you're gonna be complaining. This number 2 can be ignored. You can move from 1 to 3 to 4, so it's 2 marks, and then after that you get your final mark there. But the key part is number 1, increase in volume, decrease in pressure. Number 2, yes, you can remove that Le Chatelier. You can just says that a decrease in pressure will favor the reverse reaction. That's what they want. Decrease in pressure will favor the reverse reaction, right? You've already talked about the reverse reaction, and then you can even leave this because it's just repetition, right? And then there is the one, more products will be formed. Okay, so I was just saying quite a lot, but these are the things. Number 1, increase in pressure. Let me underline this. Increase in pressure results in a decrease in volume. You get that. Number 2, and then you can come here to say pressure will favor the reaction that increases pressure, right? And then which one is it? More products will be formed, and then which in conclusion is a decrease, you see. So but I put all this, to try to make sense out of it. Okay, and then let's look at this now. I just have to clear that. 5 moles of nitrogen and 5 moles of hydrogen are now sealed in a 5 dm cubed container. Equilibrium is reached at that. Upon analysis of the equilibrium mixture, it is found that the mass of ammonia is that. Calculate the value of the equilibrium constant at this 9 marks. Now when you're calculating Kc, I will use what I usually use there, the moles. So you have to have your Rice table. So let me write this. Remember, it's the Rice table. that what some they prefer to say ice table, but I will go for the rice table. What does it mean? So the first one is for me to write the equation first. What is the equation? It's nitrogen. I think, let me start from it a little bit here. It's nitrogen plus 3 moles of hydrogen. It gives me, okay, for now, because equilibrium is not yet established, I want to use that one arrow equal to what? 2 moles of ammonia. This reaction is going, that's where the direction is. I'll make this one smaller because this reaction is mainly going from left to right. Alright, so we agree that this is gas, this is in gas form, and this is gas form. Fine. With that now, what we have is for me to divide my line. Okay, let me use something else like this. Alright, so this is what I have to come up with my table as quick as I can. Let me not waste time here. Alright, I think it's done now. I have that one, but let me just do in case it needed more. Alright, so now remember I said you are doing your rice. So what is the first one? Let's have our ratio. There is the rice, and then the last one here is the equilibrium. I will do it with white intentionally, so that's where the answer is. Okay, it's fine. This one I will call it the equilibrium. That's where you want is the equilibrium. What? Equilibrium concentration. Alright, concentration, where you say C is equal to N over V. Very important partner. The C is equal to N over V. I can write it with something different. C is equal to, where C stands for what? Concentration. On the formulas, it's N over V. That's what we are having here. So this is the table. This is the standard table that you start with. So this is the first one is the ratio. The first one is initial moles. You are dealing with moles, and then the change in moles, and then the equilibrium. I'll write that for equilibrium, moles. Of course you don't have to do this because they will penalize you some marks. Now let's look at this information. What are they saying? They are saying 5 moles of N2 and 5 moles of H2 are now sealed. This is the initial at the beginning. And now means initially. So 5 moles and 5 moles. So you come here to say the initial moles. I can say I must put the ratio first, but initial moles, 5 moles of that, we put 5 and 5. But let's come to the ratio. What is the ratio? There is 1 hidden there, so it's 1 is to 3 is to 2. Look at the numbers. There is a 2, there is a 3, there is a 1. Those are the ratios. Initial moles, 5 moles, 5 moles. But look guys, at the beginning, you can't tell me that when you start a reaction already you have ammonia. So at the beginning you don't have anything here. It's 0, no ammonia. Okay, then later they are saying this is the volume. We're gonna use this volume 5 dm cubed. Equilibrium is reached at 450. Upon analysis, there is the second statement important. Upon analysis, it is found that the mass of what? Of ammonia is 20.4 grams. So now that's upon analysis of the equilibrium mixture, the mass of ammonia. So meaning we can come here a little bit and do some bit of working to say, okay, so before, let me do it up there. Since you're talking about the mass of ammonia, so mass of NH3, they gave us to be equal to what? 20.4 grams. Are you with me? 20.4 grams. All right, so now it's up to you now to rely on the periodic table. You guys must know your periodic table to say, you know, the mass of nitrogen is 14, hydrogen is 1 grams per mole. So if I can find the big M, the molar mass of ammonia, NH3, what is it? It's 14 plus 1 times 3, which is what? 17 grams. Are you with me? So with that in mind, I can come here and say, okay, now I know the molar mass. Now remember, M is N, number of moles. Check your formulas. Is small m over big M. I need to find the number of moles of ammonia at equilibrium, which is what? 20,4 over 17. And then you can get this answer by looking at that. Let me take my calculator here to say 20.4 over 17 grams. It gives me what? 1,2 grams. But don't forget, what is this? This is at equilibrium. Are you with me? Because they said at equilibrium. The analysis of the equilibrium mixture, it is found that the mass of ammonia. Now calculate the value of the equilibrium constant, you understand? So that is it. Now when we know that at equilibrium the mass of ammonia was what? Was 1,2. Why am I saying grams? It's 1,2 moles, not grams. So I need just to take this away here. It's 1,2 moles because I'm calculating what? The N for moles. Remember, N is moles. So the formula, this is the formula for moles of what? Of ammonia. Or you can write here and say in big, you can write it like this and say N of NH3. See, meaning moles of NH3 at equilibrium. Don't forget that. So I can come here now, 1.2 moles at equilibrium. I've got equilibrium moles. See this? These are the moles of oil at equilibrium, and they tell me for ammonia there is a part for the moles at equilibrium. I see. So I put that 1,2 here. And use the same pen here. So it's 1,2. Once I've done that, then I can fill up this table. Now look at this. We said this is an equation that is going from what? From left to right before it reaches equilibrium. Alright, it's going from left to right, meaning at the beginning we expect the nitrogen and the hydrogen, when the moment it starts reacting, we expect their concentration to what? To decrease, meaning their moles will start decreasing. So the change in moles here will be what? Negative. The change in moles of hydrogen will be negative. But the ammonia will start increasing. That's why there is a plus. Let me use this one. Look at the difference. Ammonia, nitrogen is negative. Hydrogen, it's decreasing, meaning it's going down because the reaction is moving from left, remember, to right. So we expect the concentration here go down, the number of moles will go down, hence negative, but the ammonia will go up, hence positive. Are you with me? So those are the things that you must remind yourself. Alright, next one is to say, alright, since I have got these values, how do I go about? So from here we move up to say I was having 0 moles on the initial moles. Now I have got equilibrium of 1.2. How did I get it? So obviously you are going to have 1,2 here, so that you're saying 0 plus 1,2 is 1,2. Are you with me? Then you move this direction. Now you move here and you move here. You see the arrows. Now in the change in moles we are using ratios. Let me repeat again. In change in moles, what do we use? We use ratios. Ratios of the equation. Let's come back to the equation. The equation says this: 1 and 2 plus 3H2, you give me 2NH3. These are the ratios. What are the ratios? The ratios are 1 is to 3 is to 2. You can play around these ratios. Let's start with the first one. To get the first one, I can actually use it in simpler versions. For example, I can take this one here and this one to say N2 is to NH3. What is the ratio? 1 is to 2. See, there is the 1, there is the 2. But now, what about the 1, 2? Remember, that's where I'm using change in moles. What about 1, 2? 1, 2 is under NH3. So I come here and say 1, 2 will give me what here? You can see for every 1 I get 2 of ammonia. So obviously you can see that this will be half, half of that, which is 0.6. So that because it was 1, I multiplied by 2, I get 2. 0.6 times 2, I get that. So in a way, you are dividing 1.2 divided by 2. Or you can use this thing of cross multiplying to say you call this x. You cross multiply like this, where you're saying 1 times 1.2 is 1.2 is equal to 2 times x, which is 2x. You're saying that. Then how do you get the x? You divide by 2 on both sides. You see the division. So 2 into 1.2 is 0.6. So the simple thing here, x is what? 0.6. You come here for nitrogen. That's where you've got your 0.6. Now, again, using ratios, you don't have to say now 3 is to 2. You can use now 1 is to 3, meaning I can erase here, not there. I can erase here to say, on this case, I've got nitrogen is to hydrogen. What is it? 1 is to 3. See? So now I know nitrogen, it gave me 1.6. So 1, for every 1 mole, I get 3 times here. So what about 0.6? It's 0.6 times 3. See? It's 3 times, which is equal to 6, 12, 18, 1.8 here. You can use the concept again of multiplying if you want, cross multiplying, whereby you put x here, you do this, cross multiply. 1 times x is equal to 3 times 0.6. See that? Which is 1.8. Are you seeing that? So you get here the answer to be 1.8. Or if you wanted to force it out, you could have used this one here. As I say, it was not necessary, but the answer was going to be the same. You put hydrogen here. Alright. And with hydrogen, it was what? 3 is to 2. But you remember, it was 1.2 here. Hydrogen becomes x. You cross multiply. So we say x times 2 is 2x is equal to 3 times 1.2. See, you divide by 2, you divide by 2. When you divide 2 into 1.2 is 0.6. Back again, 3 times 0.6 is equal to, see that, we are back to this. The answer won't change. It will be 1.8. So it's up to you how you're going to work on that in terms of the change in moles. So guys, that's how the whole table there gets completed. From here, you work on the signs to say, how do I get now this part here? Look at the signs, it's easier now. 6 minus 0.5, that's what you do. 5 minus 0.6, 5 minus 1.8, that's what you just do. So with the calculator, you've got 5 minus 0.6, it will give you what? 4.4. And the other one is 5 minus 1.8. Here it gives me what? It gives me 3.2. So here it's 4.4. Here is 3.2. Are you with me? Now the equilibrium concentration, that's the key part now. Equilibrium concentration, C is N over V. So what about C here? It will be N, which is 4.4 over our V, you come back to the question. They told us it's 5 dm cubed. The units must be dm cubed. Are you with me? So you divide by 5 here. C is N is the one that we just got, and the V is 5. You get your answer here. Again, it will be 3,2 over 5. It will give us the answer. Even here it will be 1,2 over 5. It will give us the answer. So if you can just have a calculator there to say 4,4 divided by 2 equal to what we get, 2,2. Divided by 5, sorry, equal to 0,88, and the other one, this one here, 3,2 divided by 5, 0,88, 0,64, 0,88, 0,64, and the last one is 1,2 over 5. It gives us 0,24. Alright, then from here, the question here was find the equilibrium constant. Now, Kc, you need to calculate your Kc. How do you calculate Kc? Kc is equal to concentration of products, remember, raised to their powers, over concentration of what? Of reactants raised to their powers. Alright, so which is equal to, it's very important for you to find the Kc expression here. Now, what are the products? NH3, so it's concentration of NH3 squared raised to their power over concentration of nitrogen times concentration of hydrogen, and the powers for nitrogen is what? It's 1, hydrogen is 3. See that? So now you can now conclude and say our Kc is equal to concentration of NH3, which is 0,24 what? Squared over, now the first one is nitrogen and hydrogen. So nitrogen is this one for 0, what? Just want to see those numbers, 0,88 to the power 1, and then the other one is 0,64 to the power of 3. Alright, then it can give us the answer there. And what do we get? We can do that is 0.24 squared, am I right, over 0,88 and 0,64 cubed. Alright, then equal to, then press that, which is 0,2496, which is 0,25. Yeah, then that becomes the value of your Kc. Alright guys, so basically that is that, and that's how you calculate Kc. Then says lastly, so the main part of this lesson was helping you calculate this so that you don't lose this 9 marks. Of course, you see there is 20 marks from it. That's why I answered the other questions, because it's not that it's the most important, but it almost takes 50% of the question, you see. Now they're saying the temperature is now increased. The temperature goes up, increase to 700. Alright, it was at 450, increase. That's what will happen to the value of the Kc at this temperature once a new equilibrium was reached, right? Only remains the same, increase or decrease. Now the temperature is increased, and you must know Kc does depend on temperature. Kc is affected by temperature. This reaction, what is it? We said it is exo. It's exo, meaning it what? It releases heat on its own. It gets hot as it happens. So if the temperature starts going up, automatically, where will this reaction go? The reaction will start favoring the reactants. It will reverse. It will go backward. Are you with me? So when this reaction reverses or goes backward, according to Lichetelier, it will favor the endothermic. So this side is exo and this side is endo. Hence, to remove whatever was added as the temperature, it will favor the endothermic side. Since it is going to go backwards, you see, more products will be formed compared to the reactants. So even Kc will decrease because you are now forming the products. I mean the reactants. You are no longer forming ammonia. You are now forming nitrogen and hydrogen. So if you are forming nitrogen and hydrogen, Kc starts going down. You see, you are doing the opposite of what you wanted. The yield will decrease. So they are asking you, what will happen to the value of Kc? It will decrease. They didn't say explain, but mainly it will decrease. Why? From our Kc expression, look, the ammonia which is on top, this one, remember it starts going down, and the nitrogen goes up and the hydrogen goes up. Hence the Kc goes down. Okay, so the answer there was decrease. So guys, as I said, I wanted to be bringing these to you. That's the first part. I took it a little bit slower just to explain, but in the coming videos I will look at this question from Mpumalanga, get it done. That's part 2. Part 3 we take a look at the KZN, 21 marks. In Mpumalanga one, this prelim question for September 2022, 15 marks. I like the KZN one, and the Eastern Cape one was low marks, but let's take a look at these. Watch me in the next video. Remember, subscribe. Don't lose out on any lesson. Thank you.